Alright, so today we're going to be doing lesson 6.4, notes, which is graphs of logarithms. So logarithmic functions are inverses of exponential functions. Inverse relations are found by swapping the x and y values, and you can find the log's inverse by swapping the x and y values, isolating the log if it's already not isolated, applying the definition of logarithm, so basically the arrow method, okay? So that's when we take, b to the power of y is equal to x, what we've been practicing, and solve for y. So I want to talk about what an inverse is before we kind of get into anything else. So, do you guys remember finding inverses of functions? So say we have the function y equals 2x. And we want to find the inverse of that. Do you remember what we do to find the inverse of this function? We have to swap the x and y values. So to find the inverse of anything, you flip around the x and y values, okay? So you see how I take the function or the equation and I flip the x and y? And then your goal is to then solve for the new y. So how would I solve for y in this one? Divide by 2. And that gives me y equals x over 2. So that would be the inverse of this function, okay? So that's just the inverse of a regular function. We're going to be doing logs, but I just want to remind you guys what an inverse was. So you don't need to write this. It's up to you if you just want to refresh your memory. But that's how you find the inverse of a regular function. So an inverse of a function means it's a reflection of the other function over the line y equals x. So basically, excuse me, we have a graph, and we have the line y equals x. If you graph two inverse functions, they will be reflections over this line. Okay, that's what an inverse is. So just a little intro on inverses before we get into it. Just want to mention that. So let's go ahead and find the inverses of the following logarithmic functions. So the first thing you're always going to do is you're going to flip around, swap your x and your y. Okay, so you're going to rewrite this, but instead of y, you're going to write x, and instead of x, you're going to write y. Like that. Now, my personal preference is to always have my log on the left, because it'll make your life a little bit easier. So let's go ahead and do that. So this is going to be log base 2 of y plus 3 is equal to x. So all I did was I just rewrote it, so I just flipped so the log is on the left. That's it. The reason I do that is because it helps me do the arrow method easier. So to solve this, it's going to be 2 to the power of x is equal to y plus 3. And our goal is to solve for y. So how would I solve for y here? Good, I would subtract 3 on both sides. So that's going to give me 2 to the x minus 3 is equal to y. And you can rewrite it so you have y equals, because usually that's how you see equations. Same thing. And this is your inverse, okay? So we talked quite a bit about the relationship between exponential functions and logarithmic functions, how they reverse each other, how logs find missing exponents, and that's because they are inverses, okay? So that would be the inverse function. So any questions on how to find the inverse function for part A? All right, let's go ahead and try part B. So the first thing you want to do is you're going to flip your x and y. So you're going to rewrite it, and your x is going to be your y, and your y is going to be your x. The next thing you're going to do to make it easier is to write it so that just basically flip it around so that your log side is on the left. So you just rewrite it, but you just flip what's on the equal side. The next thing you want to do, if necessary, is get the log by itself. So how can I get the log by itself on the left? I need to do what? Good, I need to get log by itself, so I need to subtract 5 on both sides to get log by itself. So that's going to leave me with log of y minus 1 is equal to x minus 5. Now from here, we normally would do the arrow method, but what do you notice this log is missing? A base. So what's the implied base of a log that doesn't have a base? Good. And now we're going to use the arrow method. So 10 to the power of x minus 5 is equal to y minus 1. And then I need to get y by itself. So how can I get y by itself? Good. We're going to add 1 to both sides. And that's going to leave me with my final answer, which is y equals 10 to the x minus 5 plus 1 as my answer. Just like that. So does anyone have any questions about B? Alright, let's move on to C. So now that you're starting to get the hang of it, we're going to flip our x and y. And we're going to rewrite this so that the log side is on the left. Now in this case we have a special kind of log. What kind of log is ln? What do we call it? Yeah, log with base e, the natural log. So anytime you have ln, you can always rewrite it as log base e, because it's an implied base of e, of y plus 4 is equal to x. And then from here you can use the arrow method. E to the x is equal to y plus 4. And then what's my last step in solving? Yeah, subtract 4 on both sides because I need to get y by itself. So that leaves me with y equals e to the x minus 4, and that's my inverse. Excuse me. Alright, so So now we're going to talk about graphing logarithmic functions using the inverse method. So using a logarithmic function's inverse is one method you can use to help you graph a logarithmic function. So, in order to graph its inverse, we first have to find its inverse, right? So we're basically going to be doing what we just did on the last slide. We're going to find this inverse, okay? So the first step to find an inverse is do what with my x and y? Good, put them in each other's place. So they're going to be x equals log base 2 of y, like that. What's my next step? Log goes to the left, L for left. So the log goes on the left side. Flip them around so log is on the left. Then what's my next step? We did that step already, but good. Yes, you're right. So here we're going to do the arrow method, right? Remember this part? So you use the arrows. So that's going to be 2 to the x is equal to y. Which you can also, when you see it, an equation, you usually see it y equals 2x. You can just flip it back around. So any questions on how I got the inverse here? So this is our inverse. So we're going to use one table for the inverse, and we'll make this table right here the inverse. Y equals 2 to the x. And the other table I'll do in pink will be the original function. So we got a table for each one. Alright, so for the inverse, we're going to pick some x values. Now remember, we can really pick any x values we want, but we want to pick some that are easy to work with. So I'm going to use 0, 1, 2, and 3. And we're going to evaluate these. So you're basically plugging them in for x. So what's 2 to the 0 power? 1. What's 2 to the first power? Good. 2 to the second power? And lastly, 2 to the third power is?
8.
8. Very good. So everybody see how we got those values in that table? We're plugging in these x values to get the y. Now, in inverse function, we found that it's the inverse of the other function. Anybody have a guess on what we could do to find these table values pretty quickly? So, do you guys remember in geometry when you learn about transformations? You remember reflections and all that? Anybody remember what the rule for a reflection over the line y equals x is? What do you do with the two coordinates? You flip them. So wouldn't we do the same thing here? So your x's are now your y's, and your y's are now your x's. And that's how you can find the table values for an inverse of a function. So now we're going to graph both these functions. I will do the log one in pink so we can keep track of everything. So I'm going to scroll over here so we have some room to graph. So I'm going to graph the exponential function first in blue. So that's going to be 0, 1. That's going to be 1, 2. 2, 4. And 3, 8 isn't going to fit on the graph, so we'll just leave it off. And now we're going to plot the points for the pink. We won't connect them yet. I'll explain why. So it's going to be 1, 0, 2, 1, 4, 2, and 8, 3. So before we graph an exponential function, do you guys remember that thing we had to find first? Starts with an A. Back in 6.1 we had to find the, do you guys remember the asymptote? You guys know what I'm talking about?
Yes.
So does anybody remember how to find the asymptote of an exponential function? It's always y equals your k value. So the k value is the value that's added to the end of the exponential function. So do we have any value added or subtracted to the end of this function? So what's my k going to be this time? 0. So the asymptote for my first original function is y equals 0. So let's graph that line. That's going to be a horizontal line. And it's going to be a horizontal line right here, because that's where y equals 0, right, on the x-axis. So that's my first asymptote, and that's for my blue graph. So now that we have the asymptote for my blue graph, I'm ready to connect the points, now that I see where it's going to go. So it's going to, remember, it doesn't actually touch the asymptote, right? It just gets really close to it. You guys remember that? So it looks like this. So if your original function or your inverse has an asymptote, so does the original function. Anybody have a guess on what the asymptote would be? So if this is x equals 0, this one would be, I'm sorry, if this one's y equals 0, this one would be, there goes me giving away the answers again. Yes, x equals 0. So it's going to be like this right here. X equals 0 is a vertical line. And now we're ready to connect these points. So it's going to look something like this. Remember, it doesn't actually touch its asymptote. Now, I mentioned earlier that when you have inverse functions, they are a reflection over the line y equals x. So do you guys see that? The line y equals x, see how they're a reflection over that line? Now, does anybody else notice anything special about the two asymptotes, the red and the green line? What do they form right here? A right angle, because they are what? Perpendicular. So the asymptotes will always be perpendicular for inverse functions, if they have an asymptote. So does that make sense so far, that process? All right, cool. So this is one way to do it, but we're going to learn another alternate method as well. Anybody need more time on this graph before I move on to the next part? Okay. So now we're going to talk about graphing logarithmic functions using the one base power method. All right. So the 1 BP method allows you to graph logarithmic functions without first finding its inverse. So what's really cool about this method is it allows you to avoid fractions, which you guys all like to do. All right. So when we're talking about logarithmic functions, this is what we call our standard form, okay? And anytime somebody refers to x minus h, this is just talking about the inside of the log, okay? So I'm just talking about the inside of the log when I say that. So whatever's inside the log, that's what I'm talking about. I'm referring to as x minus h. What's inside the parentheses. So all of these rules tell us what our points are going to be and how we find them, right? So anytime that they refer to x minus h, I just know this means what? What's inside the log. They want you to set that equal to this, this, that, and so on. That's what they're referring to. So let's go ahead and figure this out. So it says to find my asymptote, I take what's inside the log, in this case x plus 3, and I set that equal to 0. That's what the first rule tells me over there on the left. See, rule 1, step 1 says take what's inside and set it equal to 0, and that will be your asymptote. Once you do that, you should be able to solve for x, and what do you get when you solve for x? -3. That's your first step. You found the asymptote. Now you're going to identify the base of your log. What's the base of this log? 2. We're going to need that. So the next step for the BP method says to take the inside of your log and set it equal to 1. So you're going to take the inside of your log, x plus 3, and you're going to set it equal to 1. I'm sorry, not 0. Why did I just write 0? I just said 1. That's right, 1. And then this column here wants you to solve for x. So if I solve this for x, what would the answer come out to be? -2. The next step tells me to take the inside of my log and set it equal to b, which is my base. What's my base? 2. Then we're going to solve that for x, and what do we get when we solve that for x? Good, -1. What does the next rule tell me to do? Good, set it equal to b squared. And what is my base squared? 4. Solve for x and I get 1. And the last one is take the inside of your log function and set it equal to the base to the 3rd power. What would that be? 2 to the 3rd power is 8. And then we're going to solve this by subtracting 3, which gives me 5. All right, moving on. So from here we have our x values. That's what we were able to find, and that's why we do this method. Okay, it helps us find the x. So now we have to take these x values and plug them into the actual log function. So we take our log function and we plug in for x. So it's going to be -2 plus 3. Now, there's kind of like not an extra step for space here, so I'm going to just erase that once we evaluate that. What is negative 2 plus 3? 1. So this is going to be log base 2 of 1. So I'm just going to be doing that on these problems just to kind of show you what I'm doing, but then just to actually solve it right there. So this is going to be log base 2 of, and it's x plus 3, so it's going to be negative 1 plus 3, which is what? 2. What is that noise? Oh my God. So this is going to be log base 2 of, and this is going to be 1 plus 3. What's 1 plus 3?
4.
Good. 4. You gotta wake him up because I can't listen to this. Okay. So then from here, we are going to evaluate these. So you can evaluate them by hand for some of them, but remember how we just learned what I was talking about on the board here? So if we want to evaluate this in the calculator, it's just log of what you're taking the log of over log of the base, and that will give you your answer for that. So that's how you do it in the calculator. So if you have one of these or your phone calculator, we can practice it. So you type in 1, take the log of that, and you should get 0. Divided by 2 log equals, and what does that come out to be when you do the math? So that one comes out to be 0. Now the one in the pink we're also going to do in the calculator. So log base 2 so log 2 of over 2. And if you do that in the calculator, 2 log divided by 2 log equals, what do you guys think? 1. The next one right here, that's log of 4 over log of 2. So that's 4 log divided by 2 log equals, and that should give you 2. And then last one is log of 8 over log of 2. You don't have to write the work. I'm just showing you so that you know how to do it. So 8 log divided by 2 log is 3. Alright, moving on. So now we're going to plot these points. So does everybody understand how we got the points? Okay. So now we're going to plot them. So I'll try to color code it for you. So negative 2, 0 is right here. Negative 1, 1 is right here. 1, 2. Wait. I messed something up. Negative 1, 0. Negative 1. Oh, 1. That's where I messed up right here. It's 1, 2. There we go. And then it's 5, 3. So we have our points. Now we have to find our asymptote. So I believe we found our asymptote earlier. Right here. What's our asymptote? Good. X equals negative 3. Is that a vertical line or a horizontal line? Vertical. Very good. Like this. So this is our asymptote. So then we just connect these to get a general graph. And that is what it should look like, okay? So any questions so far?